Okay, this is ProfHelper2, and this is specifically designed to help me, especially when I have a team like the Hively team, and all 5 students are named Winston.
Okay, thank you for a great introduction. All right, so we are we're Team 17, as he mentioned, the Professor Helper group, and our team name is Peer, and we've developed the glasses for your classes. So I'm Braxton. Yep.
I'm Daniel.
I'm Andy.
Derek.
Brandon.
All right, cool. So the goal of our project was to create a facial recognition system utilizing the Google Glasses to assist professors in identifying students. So oftentimes what will happen in a course is a professor, like our customer, Professor Pisano, will have a course in which they're teaching upwards of 60 to 70 students. Logistically, it's not simple to remember every student's name. I mean, look at senior design, there are a ton of people in this course. So that's where our system comes in. It comes in those situations to help Professor Pisano, who is our customer, and like other professors. So a non-technical overview of the final state of our project would be, you can take a picture utilizing the Google Glass, send the image that you would take of a student to the cloud, have image processing done, and then what would be returned is the matching student's name. So a more specific technical overview would be the fact that the Glass app, which is written in Google Glass, the reason why I keep touching my temple is because that's the way in which you use the Google Glass. You tap the side. Sorry, it's just force of habit. So anyway, it's written in Java. It sends an HTTP request to our Amazon Web Services hosted EC2 instance, which houses both the web server as well as the facial recognition software, which is an executable file. The web server is written in Node.js using the Express framework, and the facial recognition system is written in C++ using the OpenCV library. So it also uses local binary patterns, that is the chosen algorithm of choice. And so what happens is when you send the image, it's sent on a post route to the Amazon Web Service EC2 instance. The web server receives it. It indexes into the JSON object, which contains the image. It then uses that as the input for the facial recognition system, which then compares that image to all the other images stored in the database and outputs the matching student's name to the web server, which is then returned to the Glass app. So we also have a web interface, which apparently got cut off on the bottom. But anyway, the web interface is written in JavaScript, jQuery, HTML, CSS for the front end, and the back end is written in PHP to do MySQL queries. It's used to facilitate communication with, connecting to, and management of our database. Did I skip?
Yeah. All right, so once again, my name's Andy. I was in charge of making the Glass app. A little bit about it. It's an Android product, so I developed it in Android Studio, and it uses an API of its own called the GDK, the Glass Development Kit. And to use it, the controls are pretty straightforward. You control it using voice commands, or you touch the touchpad using taps or swipes. Tap to go forward, swipe to go backwards. And so here I have a little timeline of what it will look like if you were actually using the app. The first slide, it's just the home screen. You say OK Glass to bring up the menu, and there, the second one, you see Professor Helper. You say Professor Helper, and it opens the app. Once you open the app, there's a short instruction screen. When ready, say OK Glass, take picture, and then so once you say OK Glass, take picture option will come up. You say take picture, and then the camera view will open up, and down at the bottom right, and there's a little red rectangle. And so you using the glass, you line up the person's face inside the red rectangle, and you tap again to take a picture, and tap to confirm. And afterwards, it'll crop that space out of just the face, send it over to our server, and the server will run the algorithm of the facial detection, and it will return a string of this detected student. And so here I used it on my friend Daniel, and it returns name him Daniel, which yeah.
Brandon and I were both facial recognition algorithm developers. For the most part, I handled local research and development, and Brandon will get into his part later. He handled mostly server-side stuff. So just to go into the facial recognition algorithm, it's ran on local binary pattern histograms, which is kind of what you can see there, what it looks like when it runs through our algorithm. Just putting the image into binary data. And basically what it does is it takes each image and finds this binary data and compares it with the pixels all around it. So it'll look around for all other photos to see if it can find something that matches like as best as it can. My personal part, I did a lot of research. We had a few other algorithms that we tried out that we thought didn't work. I had to collect a lot of data, a lot of photos taken that ended up having to be thrown out. Or one technical problem with the algorithm that we found out was with facial recognition. It's usually helpful to have photos from the same camera. So originally on testing, all the photos were taken with my phone, and then when we got to testing with the glass, it wasn't as accurate. With my phone, it was like we had like 34 out of 35 correct matches, and then when we got to the glass, not so much. So we had to load the web interface up with glass photos, and I don't have numbers on that, but it should work better.
So working with Derek, my side of the project was mostly just the actual deployment of the algorithm after development. That was mostly integrating with the server side that Daniel wrote, all that backend and everything to handle receiving a picture, running through training models with our database whenever that's updated. And we just basically wrote a bunch of scripts to organize stuff all as it comes in from the glass itself, and basically automate the entire process of that. And also to actually optimize the actual prediction algorithm, because what we had originally would like retrain and then predict every single time, and we got about like a 42% latency decrease from separating those. So that was basically my part.
Great. So I'm Daniel. I made the web server for the project, which handles all the back-end aspects of this the whole design. I think I'm just going to iterate what just was said before. So over there, you can see a simple visualization of how the workflow of our project works. Basically, the web server is always listening in on HTTP post messages coming from the Google Glass or the website. And every time it gets post messages, it immediately processes them and accordingly. So if the Google Glass sends a message, then the web server takes that message, extracts a photo, puts it into the algorithm, and then sends back the match name of the student it got. Same thing applies for the website. Whenever the website updates the SQL database, the website informs the web server, hey, we updated something, and then the web server accordingly updates the local database that's found on the web server itself. It's to note that the website the web server is autonomous and indefinite, meaning that it will not crash. I mean, if it does crash, it will. There is a fail-safe that it will restart the server itself. This is a nice little fail-safe in case things go bad, which I hope won't happen. And on the technical note, as said before, this is working on an AWS EC2 Ubuntu server on the Node.js and Express environments.
All right, so I'm going to talk about the web interface. So just to reiterate what I said before, connects to our remote MySQL database hosted by the AWS service. It is an RDS service, relational database system. So the requirements we have from our customer regarding the website would just be able to upload multiple students at the same time, their names, their images, audio files, and to have all modifications to the database be completed in less than 5 seconds. So we were able, okay, so we got cut off again. All right, so we were able to update the database in a number of ways. So you can add or remove an individual student. You can add multiple students to the database at a time. Now you can upload, I'm aware that professors get like a registrar, like a roster type thing from registrar, so you can upload that straight to the website and it will upload every single student into our database. And then all updates to the database are processed in less than 5 seconds. A bonus is the fact that you can clear the website, or you can clear the website's database in 1 second. There's a lovely photo of our search page to the right-hand side to search for an individual, where in which you can do one of 3 things. You can manage their images, you can edit their information. That means uploading a new audio file with the student saying their name aloud, or you can change to what their name looks like or remove them from the database. And then a bonus is the fact that the website has a login, logout functionality, which was completed using PHP session states. And then we're going to show the video. I'm so sorry. All right, there you go.
Well, we'll have to do it this way.
facial recognition application for the Google Glass. In this video, I will show you how to use our application from start to finish. First, you should navigate to our web interface to add photos of students. You can do this using the Add Students tab or the Upload Files tab for multiple students. To view these photos later, you can click on the Search tab. Next, get about 4 feet away from the student. Then, tap on the glass's touchpad to wake it up. Then say, OK Glass, open Professor Helper, open up our application. Finally, just say, OK Glass, take picture. Line up the face in the reticle and tap twice, once to take the photo, and once to accept. Within seconds, you should receive a predicted name on the display. Thanks for watching this demonstration.
Just to conclude, so we met all our initial requirements set by the customer and the beginning of the semester. The algorithm can be trained, and if you add more photos, it will obviously be more accurate. A few things that we would have liked to add would have been user functionality, given more time. If we could have like a swiping login so that you can have multiple classes, so that you don't have to have let's say you teach 3 classes, you don't have to have 300 students in one database. You can have 100 in this one, 100 in that one, 100 in that one. So it'd be a little bit more accurate. Thank you.
What's the average latency on getting the right face?
So latency between taking a picture and getting something back is about 2 to 3 seconds.
Okay.
Yep.
And is there any sense of foreground and background? So let's say I have many students and they're all in this lecture hall, and I want to take a picture of one, right? There's a good chance that you'll get some other student in the background or something.
Yeah, so how we got around that is the red reticle, or the rectangle, it'll crop whatever's in that area. So generally you try your best to put the face inside the rectangle. And then, yeah.
And the app is meant for usage like on a one-on-one or a one-on-a-few scenario, not in a huge lecture hall, so you'd be like maybe 4 feet away from them.
There's a lot of user interaction in this. Were you able to perhaps, I don't know, I'm not familiar with the Google Glass API, but were you able to perhaps tap into like the stream of video constantly and maybe detect spaces as they come up?
That is one way we could have done it, but the way we chose to do it was just to use photos. Yeah.
I think
Yeah,
one of the
streaming, yeah.
things that we decided when we were trying to figure out how to do this is that we wanted to have the photos come up, and like what you're saying is to look for photos constantly and just always be saying this is this, this is this. One of the things we wanted to do, which we didn't get to also, was like having an accept or deny option so that we could store those accepted files. So we didn't want to have a bunch of photos constantly streaming, so that way we wouldn't have just a bunch of stuff in our database and clog it up.
And also, if you do have the glass constantly streaming video, then it's going to be, it actually does heat up quite a bit.
A lot.
So
It's really bad.
Last question.
The filtering method you used is pretty sensitive to variable light conditions. Did you explore any other classifiers or methods to deal with that?
Are you
Well, in initial development, we did try eigenfaces and Fisher spaces as well, but we settled on local binary patterns because it was faster and it was more accurate for the dataset we had.
All right, thank you.